We're live. Hello, everybody attending. Nice to have you here at J Champion Conf. We are today with Keto Man. Hi.
Hello there.
Um, really happy to be there actually because we don't know each other really well, so it's nice to meet a new Java champion and that
Yeah.
I'm rarely seeing actually. Yeah. Um, So Keto, and which is a bit weird because I've been involved in Java for like 25 something years. You've been involved for about 20 years, so we should have crossed more than what we actually did.
You think so? Although you do look very familiar though, so you know.
Yeah, we met, but not as much
Yeah, yeah.
as other Java champions.
Maybe not.
So I'm happy to be there with you. Please ask questions whenever we want. I'll step in and ask them, and from there, I'll let you go. I think.
Okay. All right. So hopefully everybody can hear me. You can hear me, right, Henry? We already did that part,
Yes.
so we're
Yeah,
good.
we should be good.
Okay. So do I need
Then
to?
put
Okay. There we
I
go.
put the slides, and I can remove myself. Yeah.
Goodbye. All right. So hello. My name's Keto. This session is called "Expect the Unexpected." And we're talking about the joys of enterprise exception handling. Fun stuff. So, just a few words about myself. My name is Keto. I'm the principal consultant at Virtua, where we do training, consulting, mentoring, etc., on a variety of technologies. Obviously, focusing on Java, microservices. We're heavily involved in Jakarta EE. And on the front end, we will work with whatever framework our clients want, but we prefer web components, TypeScript, Angular, all that kind of fun stuff. Um, we're also working on a project called Speaker Tracks, which is a new product for frequent speakers. So if you like to speak at conferences and things like that, I encourage you to check that out. Um, we're an official partner of PrimeTech, which builds a few great open source UI libraries. PrimeNG for Angular, they have a Vue library, a JSF library, a React library, etc. So if you've heard of those products before, we're definitely involved in that ecosystem. I wrote a book a long time ago. And if you like podcasts, I encourage you to check out stackedpodcast.com. It is a every month or two podcast about enterprise development, and really it's just focusing on front end and back end and just tech trends and software development in general. And usually we have an esteemed guest, a lot of Java champions on, and just other people in the industry as well. So if you like a podcast, you should check that out. I'm also involved, as I mentioned, with Jakarta EE, and I used to be involved in the Java community process. Now most of these specs have gone into the Jakarta EE world as well, and I speak at lots of conferences. So that's my story. I did want to ask the audience a few questions. So if you guys could just type in the chat, like, whether or not you are a junior developer or senior developer or somewhere in the middle, and just how long you've been working with Java, that would help. And sort of give me an idea about, like, sort of the audience and what sort of background you might have. So if you can put that in the chat, I'd appreciate it. And I think it'll show up here. And maybe not.
It is. Oh, I'm big. My God, it is. But there's a little delay.
Okay.
Mary is saying hello, but Mary, yeah. So seasoned developer.
Okay. Cool. Hello, Mary.
And now you have senior 7 years, 25 years.
Ooh, 25 years. Wow. Okay.
Yeah.
So if you've been doing it for 25 years, this might be a little boring, but
there's programming since 1970, so that's even though that's older than I am.
Yes.
Okay, you have 10 years, 23 years, so you're more in the season realm, I'll say.
Season realm. Okay.
Yeah.
All right. Good to know. So So I'll also couch this in terms of what you might think about when working with, people on your team, because these are things I see on lots of different projects. So, all right. If I can press the right button. There we go. So we all know that bad things happen, right? And Henry, can you make me smaller? Oh, awesome. Thank you. It's too big looking at myself that way. All right. So bad things happen, right? There's awful weather, traffic jams. This is in India. And one of the things we often hear from developers is that should never happen. And I love this phrase. I'm always like, well, yeah, that should never happen, but you need to account for cases where it does. And hold on, let me go. There we go. You could have awful tornadoes. That should never happen. This should never happen, right? But they do. And a lot of times some bad things seem minor. So, this seems like not a big deal. It's like a little hole, but, it's a rusted pipe. Obviously, if there's fluid going through there, it'll come out. So it seems like not a big deal, but it is. Potholes are another example. It's a little hole in the road, but over time it grows bigger and it gets to a point where it might cause an accident or cause damage to a car. So small problem at first grows big very quickly. And even when it's small, if you think about a pothole, like if you weren't, let's say you were looking at your phone and you go over the pothole, you're going to lose control of your car. So even though it seems small, it actually can be a big problem. So if you think about what the word exception means, it's a noun, right? It means something accepted, an instance or a case not conforming to the general rule, okay? And, we as developers like to think in terms of rules and patterns and things like that. But we often find when our systems go out in the real world, they encounter realities we don't actually expect, okay? So we need to be able to expect those bad things. So when you're building software, it's important to try and think about all the bad things that might happen, not just the happy path. And basically, what you want is your application to behave consistently. And given the same input, the results should be the same. And this is something I think all of us have run into. It can happen in all sorts of systems. But I think a good example of this is, if you're working, if you're just trying to check out of a shopping cart on a website. We've all been in situations where it just behaves really inconsistently. There's something weird going on, or it thinks we processed our credit card but it didn't, or there's just some edge case that it's running into that's causing really inconsistent results. So you definitely want to try and avoid those things. So what I want to do is spend some time going over some basic exception handling aphorisms. And these are applicable, of course, to junior developers especially, but also to people who've been in the field for a while, and also should give you some things to think about in terms of working with younger developers that may not be quite as experienced. So the first thing I want to point out is that you should not eat exceptions. And I want everybody to remember this face, okay? So next time you're doing a try catch and just, eating the exception, I want you to remember this face. Don't do it. And I do see this in people all across the spectrum in terms of experience. So this is a common example of how people eat exceptions. So this is a JSF method, but it could be any code. The point is, we're doing some work, we're catching an exception, and then we're just logging it because you're supposed to log stuff, right? But we're not even using a logger. We're just calling e.print stack trace, so the stack trace is there. And then we go on about our business. So what's happening here is, even though the exception was thrown, we're continuing work, right? So we're displaying that a widget has been created successfully, and then we're doing some work. So the user sees a message saying, hey, this was done. This work was completed. But in reality, it wasn't. And there's an exception in the log somewhere. And it may not be even in the right logs because we're not even using a logger. So this is the number one thing I want to leave you with, and I see this so much in so much code, all across the spectrum. So if you don't, or if you aren't actually catching it, well, let me take a step back. So basically, if you can recover from it, you should catch it and log it and tell the user. Okay. So in this case, we can recover, right? So we're like, we don't have to crash the application, right? But we do want to actually tell the user something happened. So we're saying, hey, we couldn't actually talk to the database, and we do some logging properly to say that, hey, there is a problem accessing the database, and then we log the exception. Okay, so this is fine. This is basically saying, okay, we have the ability to recover from the negative behavior from whatever happened and tell the user what went wrong. Okay. But if you actually don't know what to do with the exception, don't catch it. This is the key thing. Everybody feels like, oh, it's throwing an exception, I need to catch it. And this is partially due to the way Java has all these checked exceptions, especially in older code that uses a lot of checked exceptions. So we feel like we have to catch it. And I will tell you straight up right now, I generally do not like checked exceptions because of this. But generally speaking, if you don't know what to do, don't catch it. So here, we're not actually catching anything. And what's going to happen here is the exception should be handled by something higher up in the stack. Okay, so this approach, does require that you have some higher level exception handling, which we'll talk about. But most applications allow you to do that pretty easily. So this is basically saying we're doing something. If there's a problem, this particular class doesn't know what to do with it, so it's letting another class handle it. And maybe the proper thing is for the application to crash if there is nothing there to handle it. Who knows? But the idea is that if you don't know what to do with it, don't bother. So another thing I want you to think about is meaningful exceptions. So what I see often is something like this. And this is fine. I mean, it's okay. If there's a problem, we're throwing an exception. Obviously, this is a very contrived example, but there's some issue, we're throwing an exception. But if you think about what actually shows up in the logs, and I spent a lot of times looking at logs in my career, you get something like this. So this doesn't really tell me much when I'm looking at the logs. It's like, okay, well, in the legal message, a bad argument was sent in here somewhere. But you can very easily make this a little bit more meaningful just by sending a message. Okay, so messages must have more than 4 characters. So now I know, okay, something sent an invalid message that was too long. Okay, so this gives me a little more information. And if you think about when you are throwing exceptions, you generally want to provide as much information as you can, because some poor person is going to have to spend time looking at these logs, whether it's manually or writing tools to parse logs, or queries to parse logs, things like that. So you want to make sure your message is actually meaningful. Another thing you want to do is make sure that the exception type is actually logical. And I see this too. A lot of people are like, well, I need to throw an exception. I can say what it is. But remember, Java has types, and there are lots of different types of exceptions for a reason. You can do lots of different things based on the type system that's more informative than just a string, right? So if you're throwing an exception, you should throw an exception that actually says what it is, so that we can tell at runtime what type of exception it is. So this does tell us, service is not available, which is good, but we can go a little bit further and say well, I'm sorry, this is what we see in the logs. We can go a little bit further and have an actual exception type, right? So we have to throw an outside service window exception. Now it's completely clear what that means. You don't even have to have a message unless you want to say, details about the window, and the window is really this window and the request was inside of this window. You can provide that detail. But at least now you know that there is an actual, what the actual exception is. And when someone's looking at the logs, they know what it is. Okay, and this also means that you can do different things based on the type of the exception. So this is another key thing. So obviously, when you do this, you can write all sorts of little exceptions. They may not be that complicated. That's okay. We're just using the type system. And you also can, if you have some important requirements about around the way exception handling is done, you can create your own base exception that does some fancy stuff. Maybe it parses stuff in a certain way. Maybe it has a certain log message format. Who knows? But you can, at the very least, have some specific exceptions for the problems that you have. So another thing we want to do is if something goes wrong, strive for consistency. And this is a pretty common thing. If you have a, any sort of resource you're talking to, like a database session or a network connection or something like that, just make sure it's closed. This is pretty standard stuff. And remember, Java has had the try resources block for a long, long time. So just use it, and then automatically, pretty much most resources support this feature. So you can basically ensure that it's closed this way. If not, you can use a try finally block as well. So just try and make sure you close those resources. So one of the main problems, let's go back to eating exceptions, is that it really does cause inconsistency, and we want to strive for consistency in our systems. So if you go back to this, the reason this is inconsistent is because it's telling you the widget is created in two different cases, right? One in the case where it is created and one in the case where it's not. So again, anything that happens that is going to cause inconsistency in your system's behavior based on a negative force, you want to try and handle. Okay, so another aphorism, system out println is not a logging framework. It's fine to throw a system out println in there for some random, testing, debugging stuff, but make sure it's not there when you actually do your PR. You can use a logging framework consistently. And what I've seen is, most code I've seen actually does use logging framework, most of it, but they don't always use it consistently. And there still is usually some code in there somewhere that is using system out println. So you want to try and avoid this. Hello, Henry.
Hi. 2 questions. No, there was one comment about the fact that IDEs are generating the stupid break stack trace frequently when you wrap the exception. And
yeah. Well, that's true. Yeah, some of them do that, but I think you can probably turn that off. I mean,
I'm changing it. So for myself, I throw runtime exception. So I'm changing the IntelliJ template systematically. But yeah, we could try to advocate that it should be the default pretty much.
Yeah.
The other question was, I'll read it. What is your take on adding custom exceptions versus using existing exceptions with meaningful messages? Do custom exceptions really add that much value to login if you have meaningful log messages?
I would add that they do, because types are more powerful than random strings. So we see this in software all the time. People use strings and they can change. Someone might change the message. Someone might make it more clear, right? But it's less likely they're going to refactor the exception, change the name of the exception randomly. So I know that if I'm searching through logs, if I'm searching for a type, it's much more consistent than searching for a message. So I still think having, some specific exceptions are good. There's no problem with reusing existing exceptions if they make sense. So like the legal argument exception is a pretty common one, null pointer exception, whatever. There's no reason to create your own versions of those. But I think if you have scenarios which are specific to your application, you should just make a few exceptions. Usually you don't have to make that many. So I still think it's worthwhile.
Thank you for him. I do agree. Ciao.
All right, thank you. So one of the things I want to point out too is if you work on the front end, also use logging framework. The front end's a little bit better because, well, it's not actually a whole lot better. So in Java, we have the JavaUtil logging framework by default, which honestly is not that bad. I wish I had a couple extra methods, but usually it's pretty useful. On the front end, we have console.log, which is pretty handy. Most developers use that all the time. But the logging frameworks give you give you more features and give you more consistency. So it's worthwhile looking into a log framework on the front end as well as the back end. So this is another aphorism. So what you want to do also is try and, if you can, make your output consistent. Try to use the same formatting and maybe the logical locations that make sense. Like if you're using a container environment, the logs should go in like a certain location. When I talk about formatting, I mean things like date, time, thread, method, etc. The more consistent you can make those, the easier it's going to be for people working with multiple applications, and of course within the same application as well. And remember, like, the logging frameworks are always all super flexible, so you can add all this information to help figure out what's going on. And everything from like the thread also to like an MDC or whatever you need in order to determine the context of the actual error. Another thing you want to do is not log an exception more than once. So I think we've all seen this scenario where you go look at the stack trace and you see the same exception like 20 times, and you're like, what? I don't know what's going on, And that's because people do a couple common things. So I actually have a demo for this one. And that's, this is the correct code. All right, I'm going to make this a little bit bigger. Okay. All right, so I've got a little bit of code here. And you see in my main method, I'm creating my good service, and then I'm basically passing it into another service, which is just going to call repeatedly. Okay. So if I look at my send message method here, it's just going to send repeatedly stuff to this other service here. So when I run this code, this is what I end up seeing, is this. Okay. And I think a lot of us have seen this in a while. So you see, oh, okay, the error is that this message must have more than 4 characters. Okay, fair enough. But it's here, and then it's here. And often this won't be exactly the same, the same call, but you'll see lots of different exceptions logged. You're like, okay, why am I seeing this so many times? Wow, I see it over and over again. And then I'm also seeing here, okay, so this is where it actually happened, right? But I saw it all over the place. And the reason for this is really, really very simple. It has to do with the e.print stack trace. So it's that desire to actually always log things. So the actual service itself isn't doing anything wrong. It's just, throwing an exception if there's a problem, right? So this is fine, okay? But the service that's calling it, it's doing e.print stack trace. So it's doing this, which is going to call it repeatedly 10 times. And then it's actually printing stack trace. And then it's also throwing the exception. Okay. So if we get rid of this print stack trace, right, we could run it again. And we still see it in lots of places. And that's because there is another one. Let me. Here in this code that's calling repeatedly, it's also doing it as print stack trace, right? So if we get rid of that and that, we end up with this. Okay, voila! It's just one stack trace, right? Because what's happening is we're making the call, right? It's in repeatedly throwing an exception, and then this is throwing this message failure exception. Okay, and so what we get is message failure exception. Whoops, sorry about that. I need to find out which window I was in. There we go. So it's saying message failure exception, and then it's giving you the root cause, which is legal argument exception, and then it gives you the proper stack trace. So usually that whole duplicate stack trace problem is just because everybody feels like they have to log everything. So usually it's because they're logging it and swallowing it and eating it, or they're logging it and then rethrowing it. So then you get it in multiple places. So just try and avoid logging things when you don't need to. If you're rethrowing it, there's no reason to log it, because something at the higher level should be doing that catching for you. All right. So that's the demo. Another thing you want to do is use tools to analyze logs. So if you use an APM or observability monitoring tool, usually it'll support some sort of log ingestion. So you can suck all your logs into it and then run queries against it, which is always very handy. These are some common tools: Splunk, Datadog, CloudWatch, Logs, Azure, whatever. If you want to go open source, you can use Elk. But there's all sorts of tools that do this kind of stuff for you. And of course, you can still use grep search logs, but these tools make life easier, especially if you have lots of different services and lots of logs to work with. Another thing you want to do is capture client-side errors. And this is something that really wasn't that common until more recently. So if you have a JavaScript client, using whatever framework people are into these days, you want to ensure that you know what those errors are, because often there can be exceptions thrown the same way they are on the back end on the front end, like people just logging exceptions and then continuing their work as if everything is fine. Or even worse, if there's a real major error on the client, you don't know it unless you actually send it back to the server, because otherwise it's just living on the user's browser. So there's a few different things here. There's a logging framework called LogLevel, which you can look at just for general logging. But there's there are a few different tools that'll do this sort of client-side capturing for you. Sentry and Rollbar are a couple. But at the very least, even if you don't want to use a third-party tool, you could just have a little microservice that gets a call from the client and then logs it to a proper location that can be ingested or analyzed. So you could do something very simply like that. That's not a lot of effort. So basically on the front end, if you catch an exception, you then send it to the logger, and at the very least, you know what happened on the client. So try and capture client-side errors as well. This is something I don't think people do often enough. And of course, if you have major errors, you want to notify people when they happen. So a lot of times I'll see situations where there's all these exceptions being thrown in the logs, and then like months later, people are like, oh, hey, this problem is happening. Oh, maybe it's related to this exception. And if there was any actual upfront analysis of logs to begin with, then maybe they wouldn't have had this problem ongoing for a while. So you can do this in a few different ways. You can, in your logging framework, you can have special appenders that, send messages or, some sort of notification when an important error occurs. If you have any sort of log analysis tools, they all have alerts that can be created based on errors as well. And the problem, of course, is sort of the signal to noise ratio, right? A lot of us have applications that unfortunately do log errors that are not important. And if they're not important, maybe they shouldn't be logged as errors. Or if they are, they should be handled. So it's something to consider as well. But just having the ability to, or process in place to look at the logs and understand when errors are going on is going to make a big difference. So another thing you want to do is, if you can, define an error response contract. So basically what we're saying is that, if you have, let's say you have a REST service, a whole bunch of endpoints, and you have a client or multiple clients talking to it, you want to have a standard way that you actually handle those errors, right? So of course you want to make sure you're using the proper HTTP response codes, like 500, 400, whatever it is, and that the client understands that whoever's writing the client understands that. But also you can go a little bit further than that. So you can actually standardize the JSON format that's being sent back and forth, so that if there is an error message, you actually have a standard way that it's sent back to the client, so they can make a more informed decision. So GraphQL does this really nicely. GraphQL, if you don't know, is something that you can use instead of REST as a way to just do client-server communication. So it has its own little protocol, and it uses JSON back and forth, has a little query language and stuff like that. But what's nice about it is that it actually has a way to represent an error. So any GraphQL server, if there's an error, it represents it always in the same way, which is nice. So if you have like a GraphQL request, this is just a query saying, hey, get profile. This is actually from our Speaker Tracks app. So it's getting a speaker profile. And the error that you get back if there were a problem with that speaker profile will be something like this. So this is a validation error. It tells you what the problem was, the argument ID, etc. Tells you exactly what the problem is, right? It tells you the line, the column, etc. So no matter what's going on, if you have a GraphQL server, it's going to give you an error message like this. And it does have the ability to define extensions. So if you want to say more information about what's going on here that's specific to your application, you can put it here. But the point is, even if you're just writing a REST endpoint, is that if you want to be able to consistently provide information back to the client, you can just define your own JSON message error format. So you can return like a 500 error with an actual payload that provides more information about the error in a standard format. So something to consider, just providing a standard response contract for error response contract for your clients. So a lot of these tenants work out really well if you centralize your exception handling. So this is an important thing. So most frameworks have the ability to have a centralized exception handler class or classes, and they can do things like logging. They can log things at the top level. So if you threw your exception way down, in some backend logic, and then it bubbles up, it'll get logged somewhere, right? So that's probably the number one thing they'll do is handle logging. They'll also they can do notifications. If they need to be able to send a message or something else, they can do it there. And of course, if it's a UI thing, it can have an error page. So they can do things like that as well. And of course, if you do have that standard error response, they can return that as well. So they can basically say, this is the exception I had. This is the format, of the error, and it's always going to be in this format. So centralized exception handling is key. Now, if you want to do this, it's really easy to do. In Spring, you can use Spring Boot's global error controller class. If you're using pure Spring MVC, there's a controller advice you can provide with an exception handler. If you're using JAX-RS or Jakarta RESTful Web Services, you can use the exception mapper class. If you want to redirect to an error page, it takes a little bit more work, but it's doable. Micronaut has a generic exception handler class. On the front end, this is all possible as well. So in React, there's an error boundary you can create that basically you can wrap particular parts of the component tree with it. Angular has the ability to write a custom error handler. In Vue, you can do the same thing. So that's how you can handle that, the joys of the centralized exception handling. Also, what you want to do as much as you can is try to standardize your error handling strategies. So of course, if you're working in one app, you can try and standardize things in the same app. Because we all know, especially with older code bases, you may not actually have consistency along those lines. And of course, you want to try and document your standards so that if you if you have established some standard way of doing things, document it and see if you can get other teams to do it as well. It's the beauty of wikis and collaboration. Another thing you can do is try and use common libraries across apps. So if you're working with a few different applications, a few different services, etc., try and make sure they're using like the same logging libraries. Try to make sure they're using the same logging format, things like that. And if you have different languages, you can of course have some standards across languages, and maybe that's just things about formatting and basic error contracts and things like that. But if you can, don't assume that just because this language is written in Python, this service is written in Python, that it has to be done differently. It can be done similarly enough to help people work across the different applications. All right. Also, for downstream calls, you still want to handle failures. So with microservices, you want to use something like failsafe or whatever sort of facilities that your microservice framework provides. So things like retries, circuit breakers, rate limiters, etc. This all has to do with calls between different services. So you want to try and handle those as well. Because again, remember, we're striving for consistency, right? So if you just need to retry something, you might as well try that first before you give up completely. Also, you can worry about timeouts, bulkheads, fallbacks, all these sort of fun microservice interaction patterns. And of course, you don't want to forget observability. So especially when you're dealing with microservices, there are all sorts of ways you can do monitoring metrics, distributed tracing, etc. Pretty much every microservice framework is going to have some ability to help with these things. But observability is part of the puzzle too, right? Because the more you understand about what's going on in your application, the easier it is to identify errors. So keep that in mind as well. All right, so to summarize, expect bad things. They do happen. Don't eat exceptions. If you can recover from it, catch it, log it, and tell the user. That's kind of the key thing. And if you can't, don't catch it. You also want to try and throw meaningful exceptions. Try and include a string explaining what happened, and then use an actual meaningful type for the exception as well. If something goes wrong, you want to strive for consistency. You want to use a logging framework consistently, and system out println is not a logging framework. And this is something I didn't touch on too much before, but when we talk about logging output being consistent, I'm not just talking about the basic stuff like the timestamp and things like that. I'm also talking about any other particular information you might want to provide. So as an example, a few years ago, I had a project where we were building a lot of dashboards based on the logs. And using, I think it was Splunk we were using. But what we found is that if we weren't consistent about the output of the logs, it was really hard to create those dashboards. So, and in the logging statements, we're providing information about, the types of requests that were coming in and all sorts of things that were happening. So we really had to come up with a way for every single logging statement to be consistent about what information it was providing. And if you do that up front, you'll save yourself a lot of headache down the road. So, if you have a lot of sort of additional information that you want to log, of course, not personal information, but then you want to try and make sure that is done consistently throughout your application. Okay, another thing you want to do is don't log the exception more than once. So basically, don't log the exception unless you're handling it. If you're not handling it, it should be done at the centralized error handler level. And of course, we talked about tools you can use to analyze logs. Make sure you capture your client-side errors. And of course, if it's important, you want to have some sort of alert to let you know what's going on. And of course, all of this is hard unless you have centralized exception handling, which makes things a lot better. Okay, so I just want to leave you with one thing, which is don't be that guy. So don't eat exceptions.
That image is terrible.
I know, it sticks in your brain, right? You should have nightmares about this guy.
I'll put him smaller.
Oh, you're disappearing. I don't know how to have it smaller and both of our heads at the same time. We're
Here, I'll help you out a bit. I'll yeah.
Yeah, there was so let's say two questions. One is really specific about Spring Boot. Is Error Controller a good alternative to Control Advice Exception Handler?
I got the impression. I'm not a Spring Boot expert, so but I got the impression that the error controller is sort of like the Spring Boot version, and the error advice was like Spring MVC, which is predates Spring Boot. So that's my understanding, but I would take that with a grain of salt.
Can't help. I don't know. I don't remember. And then I'll bounce on something interesting about the duplicate login, because sometime when you log at really low level, you have more information you can put in the log. And so if you just rethrow the exception right away without logging, it will be logged far after, but of course you've lost the context, so you can't log the context anymore. So
is there context that you can't provide in the message? Are you talking about like the location?
You're right. It could be in the message, so the context could be put in the message of the exception.
Yeah.
Or I guess you could do a specific exception containing the information you would like to log. So what would you advocate?
Well, the specific exception could have more information, but the whatever is logging at the top level would have to know about that. So if you don't have that, then the message I think would be appropriate. But if you have the ability to do both, then hey, you could put all sorts of details in there and then log at the top level in a certain standardized way, which would be nice. But the whole stack trace should be there unless something is swallowing it in the middle, right? So you should get the whole stack trace.
Yeah, normally you would.
So really the question is, what other information do you need to provide? And I would try a message and then do the special type if you can control the top level logging. So
makes sense. And what was the other thing about that? And yes, there was something about if you're not logging right after the error and you throw, something could happen, like the server crashes in the middle and you lose that exception forever. But it's like you need to be bad luck. And
yeah, I mean, I would think that usually if the server crashes, it will log the stuff before it crashes, like it'll log and then crash, I mean, if you have a core dump of the JVM, they're kind of out of luck regardless.
Yeah, I think it's rare. And anyway, in general, we asynchronously log anyway.
That's
so
true.
You lose it anyway.
That's a really good point.
So I think don't bother about that. You're like, if your server is crashing with like a kill 9 something, you're already in big problems.
Yeah, exactly.
And don't rely on your logs to be some kind of DB transaction log that you can roll back. Doesn't sound safe.
Yeah, it's really, I mean, logs are kind of a last ditch thing, right? It's like after the fact, you maybe can figure out what the hell is going on, but they're so important. It's really amazing to me, like how important logs have become.
There are. I'm also an advocate of in development you should log at the same level as production, because in production, if you're not able to debug, like if you're not able to debug with the logs in dev, you won't be able to debug in production.
Yeah.
So,
well, and there's always that thing, like, you have to turn on the trace level in production, but you may have missed the opportunity to reproduce the problem by then.
Yes.
So you're kind of out of luck. Have you ever used any of these, like, how there's some of these really sort of really like low footprint sort of profiling tools? I guess that doesn't help that. It's really more of a performance question though. So
yeah, because and I've used them, but I've used them for performance. I've never used them to debug something, because it's in general, these tools will trigger when something is slow, and yes, you'll have a cool stack trace telling you what's going on. But if it was a bug, it won't catch it. It catches it only when it's slow. So at least the way I've used it so far, it's not of any help. So
Okay.
the logs are the thing, like aggregate, like what you said, aggregated logs and something like Lucky or Elk or something. That's a big relief, especially with distributed servers.
Yeah, it's really helpful, and it's really fun to do. Strangely, I guess I do find the satisfying to do queries across multiple logs, because there's a
Mhm.
lot of that work where you have to do queries and then collate them, and that's why I like the standardized formatting, because if you're ever doing that, where you have to write queries across multiple logs from different services, the more consistent they are, the easier those queries are going to be to write. So
Mm-mm. And adding the context, I don't think you talk about that, but like if it's, let's say it's a transaction or like a market order or something, or if it's a user connecting, having the name of the user in the log is really, really, really useful to just cross check them all around.
yes,
Otherwise, you just cry
I know,
on your way.
right, and then you add it, and then you can't find. It never happens again. But I'll add that detail because that's a good point. Because there's like MDC, the
Yeah.
session, all that kind of fun stuff that really should be there. So, all right, do we have any more questions?
I was looking, I don't think so.
Okay.
Yeah. REST is good, GraphQL is better. Yeah. And then I try to new you to no, I try not to use the debugger to see if my logs are satisfactory to investigate bugs. That's a good advice, actually.
Mm-hmm.
And apart from that, I think that's it. If anybody has a question, it's now or we'll leave.
Last call. Last call.
Yes. No, they're quiet, but thank you very much. It was really nice. People are all happy from what I've seen. So,
All right. Cool.
and enlightening. Thanks a lot.
Woohoo! Well,
And
thank you for being a wonderful moderator. This is fun.
it was my pleasure. And have a good day and rest of conference, everybody. Bye.
All right. Thank you, everyone. Bye bye.